Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Last topic is the Windows Azure database and Windows Azure storage. I'm Wei from the CCIC Senior Program Manager. Let's go through the agenda of this session. We have 4 topics. The first one is SQL in the VM. The last one is the Windows Azure SQL database. All of this is about relational database. The last 2 is the about Windows Azure storage. We have some feature in the storage. For data, we have the table storage, and for the binary data, we have the blob storage. As we know, we have many features in the Azure, such as some messaging and caching, networking, media service. All of these are packaged into the building block. For data, we have 3 offerings. Big data is talk about the Hadoop database, and the database is for the relational database. We have 2 types of relational database. One is as I mentioned, one is the SQL VM, another is the SQL Azure. And the third one is the storage. We have some features in the storage. We will talk about it in the later. Big data. As we know, big data is very hot topic in the industry. We have many new data sources such as device, sensor, and also we have to handle many new non-traditional data type. Many text file and video, photo, and stream. Okay, list of data type and data source we have to face to the large amount data volume. Okay, maybe some people want to know what that the big data can answer. We need some new insight from the big data. From tech guys, we want to know how to get the insights from the big data. Maybe the cloud is a very incoming mode. Let's talk about the Azure data management. As mentioned, we have 4 options in the data management. The first 2 is the relational. Let's go deep into the SQL VM. Microsoft provides a continuous offering from the private to the public cloud. We have some box software such as SQL Server, Windows Server. We can handle the We can use the Windows Server and the SQL Server with the Happyway to handle the physical and the virtual machine. We also offer the SVM on the Azure. We can bring the SQL Server to the cloud. This is very interesting and very easy to make you a solution to migrate to the cloud. Make it very easy because you didn't need to change anything. You can just migrate the database and your application from the virtual machine to SVM because the architect and the hypervisor layer is the same. So you didn't pay for some migration cost. Another is about the virtual network. You can use the virtual network to connect your Kubernetes to the virtual machine on the cloud. Another offer is about the PaaS. We can offer the SQL Azure database for the new application. You can use the C#.NET and PHP to access the a relational database service on the cloud. For SQL Server in the virtual machine, you can get full compatibility of the SQL Server. This means you can get a HA feature with the always on. You can get the BI feature with the analysis service and the integration service and the reporting service. You also can get the security with the transparent data encryption and the alternate feature. This is a built-in feature for the SQL Server. Another one is a low TCO. Because you, for the existing application, you didn't need to migrate or change anything. You can migrate the application to the cloud. It's very easy. You can use a familiar development framework. You can use the same management application and the monitoring application. You can use the same tools. It's the same with your on-premise data center and the cloud. The flexibility and the control, because it's just a VM. You can get the OS, you can get the admin account, you can get the login. You can control the VM. You can install the software. You can change the config of the OS and the SQL Server. So you can get all of the VM. Another is the infrastructure. The infrastructure is managed by the Windows Azure. You didn't take care of the hardware and the disk, the switch, and the network. We can support 3.9 SOI for the virtual machine. So you can get this, and the last one is controlled by the Windows Azure. There are some common scenarios for the VM for SQL Server. The first one is the migrate the tier 1, the tier 2 and the tier 3 application from the on-prem data center to the Azure VM. The second one is the build your development and the test environment on the cloud. You know, if you want to build a large-scale load test, you need too many machines to add load to the database. But in the cloud, it's very easy. You didn't need to pay to the hardware, to the software. You just pay for the usage. You can build a large-scale load test agent. You can use the agent to get more load to the SQL Server. Another one is the backup. In the 2012 SP1 SQL Server, you can get a feature. You can use the feature to back up the database file from on-premise data center to the cloud. You can save the backup file to the storage account and restore from the storage account to the VM in the cloud. This is typically to method to build another layer, have a better HA solution. The last one is extend your local data center, because your local data center maybe have some capacity issue, such as power, networking, and the room space. But in the cloud, you didn't care about that. You just use the virtual network, connect to the cloud, and extend your data center to the cloud. You can get more VM, you can get more compute capacity. Okay. Let's do a demo about SQL Server in the Azure. Okay, as Larry mentioned, we can use the management portal to create too many types of VM. Just need some click, new VM, and we can choose the not the database, but the list This type database is the SQL Azure. We just click compute virtual machine, and from gallery, we can offer some type of SQL image in there. Okay. We can provision some type of SQL server. It's a different version. Just need some click. Okay. Because this is the VM, so we need to provide the virtual machine name. And the username. Password. Okay. We can assign the size of the VM. Okay, next. We also can control the cloud service, because the cloud service have the public IP. Also, we can create the endpoint for the cloud service. Okay, we choose some. Okay, this one. Also, we can assign the storage count for the VM. This storage count is used to save the virtual machine disk for the SQL server. We also can add some other disk for the SQL server to improve the LPS. Okay. Maybe need some few minutes to create the VM, but I have completed one VM for the demo. This is this one. In the endpoint, as we know, SQL Server have the SQL Server need you to open the 1433 TCP port to connect to the VM. So we need enable the endpoint in there. But it is not the only one for the port, because by default we offer the security computer environment. So in the OS level, we also have another firewall. We have to open the port in the OS firewall. So let's connect to the The data center I used is in the China, in the Beijing. Okay. In the firewall, I enable the SQL Server port. This means we can connect from the on-premise client or data center to access the VM in the Azure. After that, you can make it easy with your familiar tools, such as Management Studio. We can use the Management Studio to connect to the cloud. Can you see there? This address is on the cloud. It's on the cloud. So after I input the login and the password, just click the connect. You can get the SQL server on the Azure. we can get the full control of the VM, because you can get the admin login in the console. Also, you can get the SA. Use the SA. You can do anything in the SQL Server. Another demo is we can use the migration. This is another SQL instance in my laptop. It just to show you how to migrate the database from the your instance on your data center to the Azure VM. It's very easy. You can just use the task. You can use the export. Oh, sorry. You can use the export the data tier application. Okay, wizard. All of us like the wizard. We can save the file, because I have built this one, replaced it. Okay. This wizard used to migrate the database from the on-premise data center to the Azure VM. This wizard will import the database, include the data and the schema. And just need some click on the VM. We can import the application. Okay. Click. Open. Next. Next. Finish. Maybe need some a few minutes based on the data volume of the database. You can migrate the on-premise database to the VM. Also, you can use the backup restore policy to restore the database on the SQL VM. Because it's a VM, it's the same with your on-premise data center. Okay? Let's explore the table. Just one table with few rows. Select. Okay, you see. You will see the data is here. It's very easy to migrate. You didn't see. I didn't change anything. Just some wizard and click some button. Another offering is the Windows Azure SQL database. Windows Azure SQL database is a relational database service offering in the Azure PaaS platform. It's full managed by the Windows Azure. This means you didn't care about the hardware, software. You just get the SQL service. SQL as a service. We have the built-in the HA solution and for the database. Each database have at least 3 copies. We can talk about later about the architect of the SQL Azure database. Okay, we also offer the scalability and the global reach feature. We can use the familiar framework. Microsoft on the Windows Azure is very open. We can use the many languages such as .NET, just use the .NET framework, and Java, PHP. Even you can use the Ruby, Python, it's okay. Also, we can support some popular framework such as the OData and the Entity framework and the Inherit. I think the Hibernate is very popular in the Java world. Okay, we also support some popular tools such as some Management Studio and ERWin. ERWin is the data modeler tools. It's very popular. Let's do some demo about the Windows Azure SQL database. But I need to say the Windows Azure database is totally different with the SQL in the VM. Most of the concept I show is the virtual. Okay. This is the web addition management tools for the SQL Azure database. But most of the time, I like to use the Management Studio because the Management Studio is very easy and familiar. This is the web tools built based on the Serverlite. I can use the tools to get some reports, such as the active user, connection, and the space used. Also, we can get some performance query. We can get some query status about the performance. Who is the top talker about the CPU, I/O? Also, we can use these tools to design. We can add table to define the schema, and we can show the dependence. In this database, we have two objects. One is the table named the customer. Another is the view named the VW customer. It's very easy tools. Let's see more detail. In the Azure dashboard, in the Azure portal, we have a feature named in their DB database. In the database, we have two concepts. One is the server. Another is the database. But the server is not the physical server. It's not the physical server. The database is not the physical database. All of this is virtual. It's virtual. Okay. But you want to know what is the database? Why I need to create the server? Because each server means you have only one master database in the server. The master database is used to control the login. This means the server is used to control the login. The database is used to also is a virtual container to organize the table and database object such as view and procedure and other something in the database. You can click the server. You can get the dashboard. You can get the database in the server. These two databases this database is virtual. Is contained in the virtual server. You can configure such as some firewall policy, and you can get some control history. But from the management tools, let's do some demo. Let's connect a SQL Azure database. You can see the address. You can see the address is different with the SQL in the VM. I can connect. We will do the same demo. In the server, I can list the database in the virtual server. Let's do a demo to import and export the database from the from the on-premise data center to the SQL Azure database. Maybe some different with the SQL VM. I can do the task and yeah. And there, I have in the menu I have a button to deploy the database to SQL Azure. It's very simple. Okay, in the connection, we will set one thing is there, the connection database. We need to connect to the master database because only in the master database you can create user database. This means firstly you should connect to the master database. Then in the master database you can execute the create database command to create a new database. So I need to connect to the master database in there. Okay, and then the new database name and addition. By default, we have two additions of the Windows Azure SQL database. One is the web edition, another is the business edition. We also can control the database size. We have some limitation about the Windows Azure SQL database. The maximum size of the single database is 115 gigabytes. Okay, this size is enough for the demo. Okay, just click some button. The data from the on-premise data will package into the some file and then transfer the file to the Azure, and the Azure restore the file to the Windows Azure SQL database. Almost complete. Okay, then let's see. In there, the new database is in there, and the table is the same. The same table. We also can write some query. Okay, data is here. Just need some click. The database migration from the on-premise data center to the Windows Azure SQL database is very easy. Let's go deep inside Windows Azure SQL database. We have, as I mentioned, it's a different software with the Windows Azure SQL database and SQL Server in VM. We have redesigned the architecture for the service. We have some different layer. The first layer is the TDS gateway. TDS is the common protocol between the SQL client and the SQL server. You use the TDS protocol to transfer data, login, and other management activity. Okay, we use the TDS gateway to hold the TDS trace session because you know the SQL Server access is need a stick session, So we use the TDS gateway to hold the station. So if you want to new database, you want to create a new database, the TDS gateway to hold the station and execute your request in the 3 copy. This means you have 3 copy for each database. All of the database is the same. It's the same. But as I mentioned, the database is a virtual. It's not a physical database. It's not a physical database. So the 3 copy, we have a primary node, and another two is the replica. We use another layer to complete the HA and the load balance and replication. Let's go deep in the another architecture. We have a few layers. The first one is the client layer. The client layer is used by the application. The application used to the TDS. But the tools such as ADO.NET, ODBC, and other some driver is support the TDS. The TDS will communicate with the service layer. The service layer is the gateway between the client layer and the platform layer. In the service layer, we used to do some connection routing, and the billing and the provisioning. As I mentioned, the provisioning is just create new database server and a new database. The new database in the physical server, just a table. This means I have many databases. But in the physical server, all the database is a group of the tables. It's a group of tables. Yeah. And this is a physical server. Not VM. Each physical server, we will set up the OS, Windows Server, and we will set up the SQL Server software. We have a single instance in the physical server. We also have a single database. This means single physical database in the physical server. Each physical server have a single SQL Server instance and single SQL Server database. Why? Because the performance. Because the single database have a single log file. We can use the single log file to improve the log performance because for the consistency, all of the data write into the SQL Server, he must write the log first, then return the result. So the I/O mode, between the log file and data file is totally different. The log file needs to sequence access. This means they are sequenced. But the data file is random. You didn't know which query used which data. So to improve the database performance, we use the single database in the single server. Okay. In the server, we have some other component. One is the SQL Fabric. The SQL Fabric is used to control the load, the workload. You know the Windows Azure SQL database is multi-tenant database. You didn't know who is in the server. When you run a query, maybe you feel not good because it's very slow. Maybe you have not neighbor. But we know the Fabric can migrate some heavy load to another some server. This is why we suggest you to use the retry logic, because maybe you have a noise user. Maybe the neighbor is being moved to another server. Another is the management service. The management service is used to the replic data between the three copies. Okay. Another is the infrastructure layer. This layer is managed by the IT. We provide a single the same hardware and networking and storage device. That is the Windows Azure SQL database architect. We also have some feature about the data. The first one is the SQL federation. The SQL federation is used to scale out your data. Because I mentioned we have some limitation in the Windows Azure SQL database. The first one is the size. Single database, we can the single database, the maximum size is 115 gigabytes. Another is the work thread. We have some limitation. If you want to more capacity of the data and you want to get more performance, you should use the federation to scale out. We can use this feature to add or remove database. No downtime. Another feature is the SQL reporting. It's the same with the VM, with the SQL reporting service. But you can use the SQL reporting to do some BI tools. You can use this feature as a BI tools. You can use the SQL reporting to connect to the Hadoop cluster, SQL database, or something we can support the data source. Another one is the SQL data sync. It's a very important feature. You can use the SQL data sync to connect the on-prem data center to the SQL Azure database. It's based on our sync framework. You didn't need to write any code, just some configuration driven. Okay. Let's talk about SQL Azure storage. SQL Azure storage is a very important feature for the Azure platform. As Larry mentioned, the VHD for the VM is stored in the Azure storage. So it's the core. Windows Azure storage, this is the you can imagine it's a big storage pool in the cloud. You can get the scalable, durable, and available storage platform in the cloud. Okay, you can get the data. You can access the data anywhere, anytime, and just pay for the usage. It's very reasonable. Also, we can offer some Restful API. You can use the Azure compute roles such as the web role and the work role to access the storage. Also, we can open the Restful API from you can use the library in the mobile phone and another device. We are very open. We can support Python, Ruby, JavaScript, there's Node.js, and Java, PHP, and other some popular language to access the storage because it's very important. Some new feature. We have a big release in the last year, and in the last big release, we support shared access signature for the table and the queue. We can define the permission on the table, such as table, queue, and the blob container. Also, we expand the blob copy. We can support the blob copy between the different storage account. This means you have a storage account in Beijing and another storage account in Shanghai. When you need to copy a file from Beijing to Shanghai, you didn't need to download and upload again. Just use the API, we can copy the blob between the data center. It's very fast. Also, we have some improvement in the geo-redundancy and the manageability. In the Azure storage, we have two offer. We have three offer. One is the table storage, another is the blob, another is the a queue. Let's talk about the table. What is table? The table is not a relational database. It's a NoSQL database. You can imagine that. It's a key value, and they can offer the REST API, and the table support the geo-redundancy. You can have the two table. One is you can have the multiple copy in the Azure. One, you can have 3 copy in Beijing and another 3 in the Shanghai. Right? In the storage, we have some concept. The first one is account. The account is the top container for the storage. You can set up some configuration and the property in the account level, such as the geo-redundancy and monitoring and logging. This is the account level settings. Another concept is the table. Table is the container for the permission. You can set the permission on the table. You can use the share signature on the table. Also, in the table, we can have some entity. Each entity have you can set different property for the entity. Also, the entity need two key. One is the partition key, another is the row key, and some property you need. Because the table is the NoSQL database, because the table structure is NoSQL database, we didn't. There's no fixed schema. You can add some schema or some column as you need. Also, the data type is now strong type. This one, the birthday, we can have different format. One is the data, another is string. Also, you can have some special property. So this is no fixed schema. You can save anything you want in the table. Blob storage. Blob storage is used to store the unstructured data, such as some photo, binary file, stream video, and VHD, such some data file. We can support 2 terabytes in single storage account. But if you want to add more capacity, it's very easy. Just add some new storage account. Okay. We have some limitation to the blob size, because we have 2 types of blob type. One is the page blob, another is the block blob. I will talk about this later. Also, it's the geo-replication for the disaster recovery. We can set also Also, you can disable the feature because the cost. Let's see some concept about the blob storage. Okay, the table and the blob storage also need the storage account. As I mentioned, you can set up some account level settings in this container. The second level container is named the container, right? You can set up the permission on this file. The third one is the file. But each file you also can get some low-level container. This slide show we can have two types of the blob. One is the page, another is blob. The page blob is optimized for the random access. So the VHD file is the page blob. Each page blob file we can support 1 terabyte. Another is the blocks. You can imagine a video. A video file we often use to sequence access, right? This is a random access. The blocks blob is optimized for the streaming. Also, you can use the blocks blob to push the blob to the CDN node. Some of the image and stream video content, you should use this type. Also, in the block blob, each block is 4 meg. This means if you have a file, you defined the blocks blob. If the file have 100 megabytes, you should have 25 blocks. Each block is 4 meg, right? You can operate the 25 blocks in parallel. This means you can have 25 threads to upload the blob. Then you just need one submit request to combine the blocks into the single file. This is some optimized. Okay, let's show some demo. Okay, in the portal we have some button. Just this storage. Okay. In the storage, this is the storage account. As I mentioned, we have some configuration in this level. Okay. You can enable or disable the geo redundancy. You can set up the monitoring and the logging for each component. You can enable the monitoring for the blob, for the table, or for the queue. Okay. Also, you can get the access key. Is the root key. Also, you can have two keys. One is the primary key, another is secondary. This means you can switch the key. The container. This shows the container. You can set up some container in there and use the shared access signature key in this level. Let's do some demo. As I mentioned, Microsoft in the cloud is very open. It's not Visual Studio. It's the Java Eclipse, right? We can use the Java to write some application. We have some open source client library. You can use the Java. You can, firstly, you can new blob client and create the container and create the blob in the container. The blob file is from the local file. I will upload the local file to the Azure blob storage. Okay. The container name is a test container. Let's check the container. Okay, not there. Let's run. It's very easy and quickly. Okay. Just refresh. Okay, the new container is here, and the file has been uploaded. To use the client library to make some operate is very easy. We offered some client library in the Java, .NET, and Python. If you want to use some special language, which we didn't support, you also can use the Restful Api to access the blob storage. So all of the client library is based on the Restful API. Okay. Let's go through the storage architect. In the storage, we have some of the layer. The first layer is the front end. The front end server will handle all of the request and response. The front end server will talk with the The front end server will talk with the partition server. In the partition layer, we have two types server. One is the partition server, another is the partition master. Partition master is used to monitoring the partition server, right? Used to monitoring the partition server, and he can this component can get the load, the workload of each partition server, and decide which front-end server should be contact to the special partition server. Another layer is the DFS layer. It's used to store the data and used to replicate data between the data center and inside the data center. Scalability. Partition is used to a range of entity with the same partition key. Partition can find out based on the load. This means P1, P2, Pn is 3 partition. We can hold the 3 partition requests in the single server if the load is accessible. If the load is increased, we can move some partition from the server 1 to the server 2. This server is the partition server. If we get more pressure, we can move the partition 2 to the partition 3. This is automatically. After that, if the pressure is decreased, the partition will move back. Another key is used to the scalability is the key. We have 2 types of the key. One is the partition key, another is the row key. If you can provide the partition key and the row key, we can get the best of the performance. Because the primary key, because the partition key and the row key just like the single cluster index. If you can get this key, you can get the best performance. The last page, I want to talk about the Hadoop. In Windows Azure, we offer the HD Insight. It's a Hadoop on the Windows Azure. But there's some different with the traditional Hadoop cluster. We used Azure Blob Storage to replace the HDFS. Why? Because you can create the Hadoop cluster when you need, and you can run the job. But after the job is complete, you can in the Azure, in the HD Insight, you can delete the cluster. All of the data and the result is stored in the blob storage. This means you should pay for your need. When you need cluster, create, run job, and destroy. The data is durable in the Azure blob storage. Okay, in our HD Insight, we also support the MapReduce, HDFS, Hive Peak, and other Hadoop feature. Okay, most of services are managed service by Windows Azure. You can use the service as you need. I think we can get enterprise level have availability and scalability. I wish you can get a good journal in the cloud. That's it. Thank you.